These are notes continuing for section 5.1 and 5.5, discussing linear systems or system of equations. In the previous video, we talked about a linear system being two or more lines, and now we're further discussing what it means for the solution or the answer for the linear system. And the answer or the solution is the point where the two lines cross. So if we were to just simply graph a couple of lines here, making it a linear system, and I ask the question, is the point that I just drew the point where the two lines cross? That's obviously not. If I were to graph two separate lines, something like this, and I ask the question here, is this the point where these two lines cross? Obviously not. And again, if I had two other lines, it doesn't matter how the two lines are, it's just that two lines or more make a linear system. And I ask the question, is this the point where the two lines cross? Well, obviously, yes, that's easy enough. And we, again, could put these lines on graph or graph paper and ask the same question. Is this red point here the point where the two lines cross? Well, obviously, yes, it is. Is this the point where the two lines cross? No, it is not. Very obvious. And the last one, is this the point where these two lines cross? No, obviously not. So it's real easy to see when you have a picture or the graph for a linear system. And we can do the same thing with a little bit of algebra. So let's say instead of being given a picture of a linear system, we're given the equations of a linear system. It's the exact same question. Is this point right here, -1, comma 2, is this the point where these two lines cross? Well, we could go graph them and see if, in fact, -1, comma 2 is the point where they cross, or we could do some simple substitution. We need to remember that the ordered pair is in x, comma y. And in order for -1, comma 2 to be the answer, it must make both equations true. So what I need to do is take -1, plug it in for x, and take 2 and plug it in for y. So on the top equation, it would read something like 3 times 2 plus 2 times -1 equal 4. Some basic substitution. 3 times 2 is 6. 2 times -1 is -2. 6 minus 2 is 4. 4 equals 4. So yes, this point, -1, comma 2, is definitely on the first line. Now, that doesn't necessarily mean it is the solution for the linear system. Again, it must make both equations true. So now I do some more substitution. I take x and y, and I plug it in for x and y. So again, 3 times 2 minus a -1. We got to watch our signs here. Minus a -1 equals 3. So 3 times 2 would give me 6. Double negative makes that a positive. 6 plus 1 equal 3. Obviously, that is not true. 7 does not equal 3. So what we would say overall is no, this point, -1, comma 2, is not the solution. It is not the point where the two lines cross. And again, if we were to look at a picture, it's very obvious. This is the point where the two lines cross. This is not the point where the two lines cross. It's the exact same question. Is this point, -1, comma 2, the point where these two lines cross? And the answer is no, because it's not on both lines. On number 5, again, I take these ordered pairs and I plug them in. 2 times -3, that's 2 times y. Remember, the ordered pair is x, comma y, minus a -4 equal -2. So I ran out of room there. 2 times -3 is -6. Double negative makes that a positive. That's plus 4 equal -2. Well, -2 equals -2. So that first ordered pair is a solution for the first line. Now I have to see if it's a solution for the second line. So now I only have a single variable equation, x equal -4. Well, the x value is -4. So -4 equal -4. I took this number, plugged it in right there. And that one checks out. So if they both are yes, well, then it is the answer to the linear system. That is the solution. And again, to bring it back to the picture here, because those are easier to understand, this is the point where they cross. This is not the point where they cross. This ordered pair, -4 comma -3, is where these two lines would cross. And we could graph it, or we could check algebraically. So let me do two more with you, number 7 and 8. I take -7, I plug it in for y. I take 5, I plug it in for x. -7 minus -5 would be -12. -12 does not equal -2, so no, it is not the answer. I don't have to check the second equation because it made the first one false. There's no point. It's not the answer. That is not the point where they cross. And on the last one, number 8, I take 0 and I plug it in for x. 0 equal 5. Well, that's no again. This is not the point where these two lines cross. So in order to see algebraically, it needs to make both equations true. If we're looking at a picture, well, we can just see this is the point where they cross. This is not the point where they cross. Hope that helps. Thanks.